So the idea of a water tower is very simple. We're going to take a big cylinder full of water and we're going to fill it up. And then we're going to turn on our hose and water is going to shoot out the hose. Okay. Let's see if we can answer the question of how fast does it shoot out the hose. And let's pretend that the water tower is height h, namely the top of the water to the spigot, that difference is about h. And let's say that this is region 1 up here, and this is region 2 down here, and both of them are open to the atmosphere. So this is open to the atmosphere, and the hose down here is also open to the atmosphere. Okay. One of the questions on your homework is, what's the pressure as the water leaves the pipe? In a different problem, but it's the same idea. If the pipe ends and the water is now in the atmosphere, the pressure is atmospheric pressure. That's it, 1 atm, 10 to the 5 pascals. So, how do we solve this problem? How do we calculate V2? Well, we go back to Bernoulli. And we say, all right, Bernoulli said that region 1, if I add up a bunch of terms, those have to be constant. P1 plus 1/2 rho V1 squared plus rho GY1, that has to equal P2 plus 1/2 rho V2 squared plus rho GY2. Okay, and this works for any regions that are connected by a fluid. So anytime you have a pipe, even if portions are stationary, other portions are moving, Bernoulli's equation is always going to hold. Now in the water tower, it's going to simplify a little bit because P1 is open to the atmosphere, and so the pressure is just P0. There's also essentially no speed of the water molecules up there. We can say that's 0. We can also say that the height, y1, is just h. We'll make ground level y equals 0. P2 is, what's the pressure in this region? It's also open to the atmosphere, so that's P0. V2 is what we're interested in. And we just said that we are at a height 0. And so now look what happens. The P0 is going to drop out on both sides. All I'm left with is rho GH equals 1/2 rho V2 squared. Rho cancels out, and I get V2 equals square root of 2GH. And that maybe sounds familiar to you guys. You've probably heard this 2GH number a lot, square root of 2GH. Where do you hear that? Anybody have a thought? Jamie, you want to give us your thoughts on that one?
I guess.
Somebody else? Were you gonna talk? No?
Free fall.
What's that?
Free fall.
Free fall, right? If I took a rock and I held it up here at height h and I dropped it, it would be going speed v2 when it hit the ground, which is square root of 2gh. This is exactly the same as free fall. So it's just like that water molecule that was floating around up there, fell all the way to the bottom with nothing else in the way. How fast would it be going when it hit the bottom? This. How fast is the water shooting out of the pipe? It's that. And so when you turn on your hose and you measure the speed coming out of your hose, what can you determine from that? You can in fact determine how high the water tower is, right? And this is why they put those things up at the top of mountains. And this is also why when your house is up at the top of the mountain, typically your water pressure is less than the people at the bottom of the mountain because the water falls further. And this also tells you that if you put the water tower at the bottom of the mountain the people at the top of the mountain aren't getting any water. You have to do something else to get them water. You have to make a pump and actually drive the water up the mountain.